In this video, we're going to talk about solving two-step equations. Again, to solve means to just find the value of our variable that's going to make the equation true. That true piece is the most important part. And to do that, we use inverse operations because these are operations that undo each other. So we talked about this in the last video, but addition and subtraction undo one another. Multiplication and division undo one another. We have things like an exponent of 2 and a square root undo each other. We're going to focus mostly on these, though. So let's take a look at an example. If they want me to solve negative 4x minus 1 is equal to 11, I'm basically trying to figure out what value of x, when multiplied by negative 4 and then subtracting 1, is going to give me an 11. To do that, we're going to use inverse operations. So I'm trying to isolate this x. The last thing that's being done to this x is subtracting 1. So that's the first thing that we're going to undo. We would add 1 to both sides. Well, negative 1 plus 1 is 0, so I don't need to write that. So I'm left with negative 4 times x is equal to a 12. Now the operation that's connecting the negative 4 to the x is multiplication. Well, to undo multiplication, I'm going to divide both sides by a negative 4. Negative 4x divided by negative 4 is just a 1x. And 12 divided by negative 4 is negative 3. So using inverse operations, I end up with x equals negative 3. But to check that, really I'm trying to see, does negative 3 make this a true equation? So we would try by substituting negative 3 back in to see if we get a true statement. 12 minus 1 is equal to 11, so I know that negative 3 is the right answer. So let's take a look at the second example. 2 times m plus 8 is equal to negative 1. I'm trying to find the value of m that makes that true. Well, ignoring this side over here, so I'm just looking right here. If I was m, I'd multiply it by 2 and then add 8. So to solve, I'm going to undo that. I'm going to undo the 8 first by subtracting. 8 minus 8 is 0, so I don't need to write that. So we see 2m is equal to negative 9. Divide both sides by 2 to undo that multiplication. And 2m divided by 2 is just m. So we get m equals negative 9 halves. So I can check this by substituting it back in. So if I do multiply negative 9 halves by 2 and then add 8, I'm supposed to get a negative 1. Well, this gives me negative 18 over 2, which is a negative 9. So negative 1 does equal negative 1. So this would be the value of m that makes this equation a true statement. Now we have s divided by 5 plus 3 is equal to 2. What value of s makes that true? Again, if I'm ignoring this, just looking at s divided by 5 plus 3. If I was s, I'd first divide it by 5 and then add 3 to simplify. So to solve, we go backwards. I'm going to get rid of the last thing I did, so I'm getting rid of that plus 3 first by subtracting 3 from both sides. 3 minus 3 is 0. So I'm left with s divided by 5 equals negative 1. Well, to undo this division, we can multiply both sides by 5 because this really becomes 5s over 5, which is just an s. Negative 1 times 5 is negative 5. So does negative 5 make this a true equation? We'll check that by actually substituting it back in. So I get negative 1 plus 3 is 2, which is true. So we know that negative 5 is the correct answer. Final one. This time, I have r plus 5, then dividing that by negative 2 should give me negative 4. So to undo that, dividing by negative 2 first, I'm going to multiply by negative 2. So negative 2 divided by negative 2 is really a 1. So we're left with r plus 5 is equal to positive 8. We can do the inverse of adding 5 to get rid of it. 5 minus 5 is 0, so we're left with r equals a positive 3. To check that, just to be 100% sure that the value I found does in fact give me a true statement, I'm going to substitute it back in. So we get 8 divided by negative 2 is that negative 4, and the answer is yes. That's how I know that 3 is the correct solution.